And is Jackie here? Alexis is here. Is Jose here? Hey, there's Jose. Get this here. Alexis. Jose. Elisa. All right. All right, well, what we're doing today, as on other review days, everybody has signed up, more or less, for a problem, and 2 or 3 people will come up to the board at a time to write up their solution. We won't pay any attention to them, because meanwhile, I'll just be walking around the room offering help. So today, this is essentially a 2.5-hour work session. You can work on finishing your practice test for chapter 8-9, or you can work on your practice final exam. If you want to start working on your practice final exam, and then as I walk around the room, I can help you with any questions you have about that as well. As you can see from the calendar, we will have a whole class period, December 5th, to go through the practice final exam. So the best thing that you can do is before December 5th, go home and try the entire final exam. You know, answer as many as you can, find out which ones you find easy, and then figure out which ones you find challenging. That way, on the day of December 5th, you can make sure to get your questions answered. Of course, between now and then, you can always just email me and say, Mr. G, I'm working on the practice final. You can email me later today. Mr. G, I'm working on the practice final. I'd like to go over number 7 with you. And then I could always email you back with a suggestion or a tip or a hint. So I would do the practice final, you know, as soon as possible. As soon as you feel good about taking your test in chapter 8-9, go ahead and start on your practice final. When should you not start working on your practice final? On December 9th? That'd be a bad time to start working on the practice final. That only gives you a day to cram. So I hope that you start, at least today, go home and look through the practice final. Just take the practice final and show it to your conscious and subconscious brain. Just sit there and flip through all the questions so that you can say, oh, yeah, okay, yeah. There you go. Like, at least show it to your brain, but I would start working on it soon. Jose? Yeah, absolutely. Oh, you need one as well? Oh, man, I just handed you your test, but I didn't give you one of these. So here you go, Alexis. There you go, the practice final, keep in mind, I already posted the solutions as well. So if you go onto your Canvas email, you'll see that I sent you an email that has all the solutions. So the entire practice final exam has already been filled out by me to show you how to do all those problems. So, okay, I suppose that's all. Then I could keep on saying, everyone go home and keep doing it. But, you know, you're going to do it or you're not. But I hope you all look at it today. All right, well, let's start with a joke. Why did the bicycle fall over? It was too tired. Yes, very funny. All right. Let's see, I guess that's it. All right, well, here we are then. I'll tell you one more funny thing. My daughter said it yesterday. You know, 2-year-olds, they're very insightful. My wife was telling my daughter how windy it was outside, and she said, what does the wind sound like? And she said, egg salad. Yeah, I don't know what she was going for with that, but it had us laughing. All right, well, the very first problem no one signed up for. So how about I go ahead and do number 1 since I'm already standing up here. And in fact, I'll go ahead and do 1 and 10 since I'm standing up here. So let's everybody turn our attention to number 1 and number 10. I'll go ahead and do those, and then we'll have everybody else walk through the problem. So number 1, solve the system by graphing. So I have a system there, y equals negative x minus 3, y equals 2x plus 3. You know what I would do if I were you, or if I was me? If I were me, this is what I would do. I would take my y equals negative x minus 3, I'd write negative 1 over 1 x minus 3. And I would say, you know, this is my slope, and this is my y-intercept. And then I'd come over here, and I'd say, okay, y-intercept, and then I'd say down one right one, down one right one, down one right one, up one left one, up one left one, up one left one. Then I'd take my second equation and say, okay, that's really 2 over 1x plus 3, and that's my slope, and that's my y-intercept. And then I'd say, okay, my y-intercept is at 3, and now I'm going up 2, right 1, up 2, right 1. And maybe I would even remind myself that slope is the up, down, over the right, left. So then I would say, okay, that's up 2, right 1, or down 2, left 1, down 2, left 1, down 2, left 1, down 2, left 1. And there we go. So there's my system, nice and graphed. It says solve the system. Well, remember, there's two definitions for solving a system. What's the first definition? The visual definition of solving a system? You find the point of intersection. So the point of intersection clearly is right here. So that's my point of intersection. That's the coordinate -2, -1, right? So that's the point of intersection. But the second definition, the more important definition of solving a system means find two numbers, x and y, that you can plug into both equations to make both equations true. And that's what I say right here. Plug your coordinate back into both equations to prove that your solution is correct. So now that I have my solution, I'll actually plug it in. So let's see, y equals -x minus 3. I'd say -1 equals -2 minus 3. That's -1 equals 2 minus 3, which is -1 equals -1, which is true. And then I'd plug it into this one, and I'd say -1 equals 2 times -2 plus 3. And so -1 equals -4 plus 3. And so -1 equals -1, and that's true. This is a really great problem. A problem that I hope every single one of you gets correct, because it strikes at the fundamental philosophy of what we did in this whole unit, which was graphing two graphs simultaneously and finding the point of intersection, which is a coordinate of double truth that will make both equations true. Yeah.
Is it possible to just do chart, like plug in points and just put an x and y value chart and then just substitute into whatever it is? Let's say if x is 1, then you know, let's say if x is 0, it's -3. Put a chart down and then graph if you did.
Oh, you mean to do the graph by doing a table of values instead of doing the slope and y-intercept? Sure, however you want to make your graph is fine.
But it's correct, right?
It would be correct.
Okay.
I mean, I think mathematicians invented M and B because it's just so much faster than doing a table of values. That's why we do graph transformations. It's just so much faster than the table of values. But a table of values is the bedrock for how you graph things. So no, you'd never be wrong to make a table of values. It would just take more time than necessary. Yeah. Okay. And then any questions about that one, folks? Then I'll go ahead and do number 10 as well. Number 10, oh good. I don't even think we did a problem like number 10 somehow in the notes. So let's everyone take a look at number 10. It's everyone's favorite kind of problem, a word problem. So a man flies a small airplane from Fargo to Bismarck, North Dakota, a distance of 180 miles. So let's see here. He flies from Fargo to Bismarck. So I'm just going to start making myself a little drawing. Here's Fargo, and then here's Bismarck. And it's a distance of 180 miles. Okay. Now, folks, this is just always what I do. It's not even necessarily for you. I mean, it is for you, but it's what I do. If I read a word problem, I start making a picture. So because he's flying into a headwind, the trip takes him 2 hours. Okay, so we're going this way. And we're talking about distance, rate, and time, so I might as well remind myself I'm probably going to end up using distance equals rate times time. So I already know that on the that way trip, my d is 180. I also know that the time is 2 hours. But what I don't know is my rate. So that's everything I know about on my way from Fargo to Bismarck. All right, is that all we know so far? That's all we know so far. Okay, so on the way back, the wind is still blowing at the same speed. So the return trip only takes 1 hour and 12 minutes. Okay, so on the way there, he had a headwind, right? So I should maybe make a note of that on the way there, we have a headwind, which means he's going slower than usual because he's moving against a headwind. Whereas on the way back, he has a tailwind, which means he's moving faster than usual because the wind is helping him go faster. So on this way back, my distance is still 180. This time my time is 1 hour and 12 minutes. So whenever you use the formula D equals RT, you have to be consistent with your units. D is going to be in miles, R is going to be in miles per hour, and time has to be in hours. It has to be that way. So you can't like convert 2 hours into minutes and say it's 120 minutes because then the formula wouldn't work. And we have an hour and 12 minutes. How do we write 1 hour and 12 minutes? Well, we certainly don't write 1.12. That's just completely wrong, right? So how do you convert 1 hour and 12 minutes into hours? How many hours is it? Is it 1 hour? No, it's more than 1 hour. Is it 2 hours? No, it's less than 2 hours. So far we know it's 1 point something, right? But what is that decimal?
0.2.
It's 1.2. How did you do that?
It's 12 divided by 60.
Exactly. So we have 1 hour plus 12/60ths of an hour. Oops, 12/60ths of an hour. Yeah, because you have 12 minutes out of 60 minutes, so you have 1 plus 12/60ths. And if you divide that, you get 0.2. So it's 1.2. So our return trip is 1.2 hours. And the rate, we also don't know. But presumably, it's a faster rate. So on the way from Fargo to Bismarck, he's going relatively slow. On the way back from Bismarck to Fargo, he's going faster. Now, also notice when you read a word problem, it's a multiple drafts type of thing. You read the word problem over and over and over again. Sometimes you just read the first sentence and then you write something down. Read the first 2 sentences, write something down. Go back and read the first sentence, write something down. Like you read the word problem probably a total of 3, maybe 4 times to make sure you understand everything. So let's just start from the beginning. A man flies a small airplane from Fargo to Bismarck. Okay. A distance of 180 miles. Got that. Because he's flying into the headwind, the trip takes him 2 hours. On the way back, the wind is still blowing at the same speed, so the return trip only takes 1 hour and 12 minutes. What is his speed in still air, and how fast is the wind blowing? What is his speed in still air, and how fast is the wind blowing?
Is still air equals 0?
Is what?
Is still air considered equal 0?
Is what equal to 0?
Still air. Does that mean
Oh.
0?
Well, let's ask, what is his speed in still air? Well, yeah, if it's still air, that means the wind is not blowing at all, and you're just flying. So if it's still air, then we're just talking about the speed of the plane itself, right? If there's no wind at all, and the plane is moving, we're only interested in the speed of the plane. Whereas the second part of the question is, how fast is the wind blowing? So, folks, whenever you look at a word problem, the question is actually the most important thing, because the question is telling you what you have to go find out. So the question is, what is the speed, what is his speed in still air? So that means the first question we want to know is speed of the plane. We'd like to find the speed of the plane itself. And then second, we'd like to know the speed of the wind. This is good to begin your analysis with understanding what the question is asking. The question is asking us to find the speed of the plane as if the plane were just flying in no wind at all. And then it's asking us to find the speed of the wind. So remember that process that we did where we said there's like a 3-step process. First, define your variables. Second, define your equations. And then third, actually solve for x. Isn't that what we did? Those are the 3 steps. So now that I know what my question is, what should our step 1, define the variables be? Define variables. What variables are we going to use? And remember, your variables always represent the unknown. Your variables always represent the question being asked. So how many variables do we have? 2. We have 2 variables because we have 2 unknowns. What variable should we use for the speed of the plane? P. So P represents the speed of the plane. And then what variable should we use for the speed of the wind? W. So we have 2 variables now, speed of the plane, speed of the wind. All right, so now how do we go about making our step 2, the create equations. Equation, parenthesis S. You never know if you're going to make just one equation or multiple equations. So what equations do we have? First of all, what's the core equation that we're definitely going to use? D equals RT. So we know for sure we're going to use D equals RT. And since we have a there trip and a back trip, there and back, then we probably have 2 equations of D equals RT. So how do we make the there trip? what equation do we write down for going there?
D over T equals R.
Yeah, we have our d equals RT. Now we know the distance. The distance is 180, so that's simple. We don't know the rate. That's the thing we didn't know, but we do know the time is 2. So what is the rate? What is the rate of going there? The rate of going there, which means we have a headwind. And the headwind means that you have the speed of the plane, but the speed of the plane is being held back by the speed of the wind. So how would I write down the rate in terms of P and W? Any thoughts? First of all, we can all assume that the speed of the plane is what, like 100 miles per hour or more? Whereas wind, how fast does wind blow? Maybe 10 miles per hour, maybe 20 miles per hour. So, just roughly speaking, the plane will be going like hundreds of miles per hour, whereas the wind will be going maybe tens of miles per hour. So, for instance, if the plane can go 100 miles per hour, but this wind is blowing against it 10 miles per hour, how fast is the plane actually moving through the air? 90. Because it's 100 minus 10. You've got the speed of the plane, but you're subtracting out the speed of the wind. This is basic relativity, right? So one fun way to think about it is when you go to the airport and you walk on the people movers. Do you guys ever walk on the people movers where you walk on that thing, and if you're walking with it, you feel cool because you're going really fast, right? You step on and then go whoosh. Do any of you ever walk backwards on the people mover? Like it's really early in the morning, there's no one around, so you get on the wrong people mover and try to walk against the thing? Have any of you ever done that? I'm sure you have, some of you have. My wife and I, for fun, when we didn't have kids, we would always go up the down escalators. Yeah, we were those people. All right, so anyway, it's really hard. So if you're in the plane and you're going against the wind, we have to subtract, right? So what are we going to subtract? Yeah, it'll be P minus W. That's our rate for the plane going into the headwind. Whereas, what about our second equation? T equals RT. Now this time we're coming back. We have a tailwind, so we're going faster than usual. The plane can go 100 miles an hour. The wind is going 10 miles per hour. So combined total, the plane is moving through the air at 110 miles per hour because you're adding them together. So what is this equation going to be? 180 equals, yeah, P plus W times 1.2. What I'd like to convince you of is that already, if you've written all this down and you've watched, already we've done really nice work. I mean, this is really nice work. I mean, if the question was just, oh, this would be so cool. What if on math tests, you were only ever asked to set up the problem? You don't need to solve it. Just set it up, right? And you earned credit based on whether or not you set it up well. That'd be really interesting. That'd be a really interesting math class. I think it'd be an interesting math class. Because really, this is the essence of what we're doing. This is the important part, is setting up the problem well. Getting the answer is routine. It's just a matter of algebra. Okay, so far we've done really good work, and we haven't even solved the problem yet. But, I mean, just look, we drew a diagram, we figured out what the question was, we defined our variables, and now we've created our own equations. And now at this point, we have 2 equations and 2 variables, and it's just a matter of doing the algebra. So, we have our 2 equations now. And I suppose I'll just keep on working right here. What should we do now? I don't know, does 1.2 go into 180? Because you have 2 ways of doing this, and I definitely want to show you the clever way and the brute force way. We've used that word brute force now. Let's consider the brute force way. I'll do it far over here. So you don't have to write this down just yet, because if you just watch, you'll say, okay, yeah, that's obvious. So I've got one equation, which I'm going to rewrite as 2 times P minus W equals 180. So all I did was switch the sides of the equation and put the 2 in front of the parenthesis instead of after. And then I have the equation 1.2 times P plus W equals 180. Again, I just switched and put the 180 on the right, and then I put the 1.2 in front of the P plus W. Okay, so now what's the traditional thing? Any traditional person would just walk up and go ahead and
You could divide or you could distribute.
Well, that's, yeah, you could divide off the 2 or you could distribute. And I think most people would probably distribute, because that's the pattern we get into in life, is we say, okay, we distribute 2P minus 2W equals 180. And then over here, I distribute the 1.2 and I have 1.2P plus 1.2. W equals 180. And now you have two equations and two variables. I write them down on top of each other, and now I have 1.2p plus 1.2w equals 180. And right here you can see the traditional system of equations that you'd solve with elimination or substitution. So what would you want to do, elimination or substitution? In this case, probably hard to solve for one of the variables. I mean, you'd have to divide everything off and then create a substitution sentence. So probably you would just do elimination. That's probably what I would do. So to eliminate, I need 2 and 1.2 to go into the same number. I think the smallest number they both go into is 6. 1.2 goes into 6. So I'd multiply this top equation by 3, and then I multiply the bottom equation by -5, and I'd create two new equations, 6p minus 6w equals 180, and then -6p minus 6w. Oh, I didn't multiply by 3. What is that, 540? Okay, and then I multiply by -5. Okay, so then that gives us 900, -900. Am I doing this right so far, folks?
Yeah.
Is that working? Okay, so now I can do elimination. I eliminate my p variable. That gives me -12w equals -460. And that doesn't go in cleanly, or does it? Oh, actually, maybe it does, or maybe it doesn't. But we divide by -12, and we get w equals, let's find out. That's a bummer if it doesn't go in either. It's just a little decimal. Oh, no, it's a terrible decimal. It says 38.3. Repeating. Did I do that right or wrong? Is 5 times 1.2 6? Yeah. We want to turn them both into a 6, yeah. So we multiply by 3. 3 times, just checking to make sure I didn't make some mistake. 540, and then 5 times 1.2 is 6. 5 times 180 is 900. That's what it was. All those are negative. Those canceled out. 900 minus 540 is 360. Oh, it's 360! There was my mistake. All right. You know, I always feel bad when I make a mistake on the board, but on the other hand, you know, the process of finding a mistake is a very important math skill as well. So you can see you just have to kind of sit there and play around with it until you find a mistake. Okay, so now that is much nicer. It just divides and becomes 30. So if that's the speed of the wind, now how do I find the speed of the plane? You have to plug it back into something. I'll go ahead and plug it into the easier equation. So 2p minus 2w equals 180. I plug in 30 for w. And then I have 2p minus 60 equals 180. I move the 60 over. 2p equals 240. And then divide up to 2, p equals 120. So before we actually go back and do the solution that I want you to write down, right now we're claiming that the wind is 30 miles per hour and the plane is 120 miles per hour. Right? So first of all, is that reasonable? Those are pretty reasonable. How do we know if the answer is right? How do we know if it's right? We just plug it in. We have these two equations that we just built. So if I plug 30 and 120 into these equations, both of them should become true. So let's check. Is 180 equal to p minus w is 90? Is it equal to 90 times 2? Is 180 equal to 90 times 2? Yeah. And then over here, if I add them together, is 180 equal to 150 times 1.2? We'd have to use your calculator to check that, but it's true as well. So we definitely have our answer. It's 30 and 120. And that's the answer to the original question. What's the speed of the plane? What's the speed of the wind? Okay, so now I'm sure you're all very excited to do the solution that I'd like all of us to do. And that is, instead of distributing the 2 and distributing the 1.2, let's divide those numbers off instead, which is what Annabelle suggested. So everyone go ahead and write this down now. Write down 2p minus w equals 180. And 1.2 p plus w equals 180. And then we can immediately just divide both sides by 2 and divide both sides by 1.2. And over here we get p minus w equals 90. And over here we get p plus w equals 150. And now these equations are much simpler to do elimination, or substitution for that matter. So I'll go ahead and now just write them stacked on top of each other. So I'll put P plus W equals 150. And now I just have this nice simple equation. I add them together, my W's cancel, 2P equals 240, and P equals 120. It's the same solution we had a second ago. But notice how much less work there was to do. I mean, look over here. Who wants to do that? Not only is this harder for you and your brain and your audience, it's actually mean. Why would you do that to your audience or yourself? So now we have P. You can solve for W practically in your head by just thinking, well, P plus W is 150 and P is 120. So 120 plus what is 150? The answer is 30. In a situation like this, you could almost just write down the W equals 30, and I wouldn't take off any points for it because it's so obvious. But you could still do it. You could say, okay, 120 plus W equals 150, and then you subtract off the 120 and you get W equals 30. Mm-hmm. Any thoughts? Yes?
So that's another way to solve for E and W.
Yeah, this is the way I would recommend it. As opposed to this way, which just adds, it just contributes a lot more computational steps that you have to do.
So either way will get us 4 points on the
Huh?
either way.
Oh yeah. Either way will get you full credit. And then folks, like if you really wanted to geek out, this is something you could do when you go home later today. You could say to yourself, well, I wonder if there's just a fast way to know the answer to problems like these. Like, let's say that you had distance equals P minus W times T1, and then you had distance equals P plus W times T2, and then you could go ahead and solve for P and W in terms of D and T. So, like for instance, just for fun, if I go and divide off the T1, so now I have D over T1 equals P minus W, and then over here I divide off the T2, and I have D over T2 equals P plus W. And I go ahead and write my P plus W underneath it, my D over T1, no T2, and I go ahead and do elimination. The W's cancel. I have 2P equals D over T1 plus D over T2. And then I can divide both sides by 2. And now I just have a formula for the speed of the plane. The speed of the plane is D over T1 plus D over T2 all over 2. And on the one end, you can go ahead and plug in the numbers and see that it works. That'd be 180 over 2 plus 180 over 1.2, all divided by 2, which was, what, 90 plus 150 over 2, which is 240 over 2, which is 120. Anybody excited by that? That you could just come up with a formula? Maybe you are, maybe you aren't. Is it worth your time to memorize formulas like this for a test? Nah. That takes a lot of mental energy to memorize a formula. You're better off just knowing how to solve a problem. Okay. Thanks, Emmanuel. Anyone else have a question about that? I'm sure that that problem is on the more software online, so you'll see that. Okay. Well, folks, what we'll do now is I'll just start walking around. When I get to you, I'm going to stand there until you ask me a question from either the Chapter 8-9 test or from the practice final. So everybody in the room should have questions that you'd like to ask or problems that you're working on. So let's have our first couple of people come up here, which is Oscar and Jose. They're going to do number 2 and 3 for us. Actually, 2, 3, and 4. Let's go ahead and have Oscar, Jose, Alexis. And gosh, Oscar, maybe you can just write number 2 up somewhere, and I'll leave the board up for number 3 and 4. And I want to leave this solution up in case somebody's still looking at it. Nobody needs to look at this one. And I'll move this up, just in case somebody's still looking at it. And there we go. So now Alexis and Jose and Oscar, you can all come up and write up your solutions up there. And I'll start walking around. Feel free to work with each other. everything? Okay. No questions? Okay. Oh, super good. Oh, and these are your notes. Okay. Question? Okay, find one to ask Mr. Ford. Okay, do you have a copy of the practice book? Yes. Okay, great. So it says right there, in standard form. You just want to find it. So what is the formula?
And then, so where actual.
Base then, but it's plus 10. But yeah, is that plus?
Yeah, I'll do it and then.
Either way. So that's our first.
So then we do these two, and then, once you're done talking, you're taking back the ducks. You go over to.
So what's the first one? And then base then just comes out because that's. And just. So really, I guess much nicer. Okay, so now T, what's our common difference? What do we add? Yeah, perfect. Just calculators and take it in terms of size. So you take any term and subtract the term. Yeah. So yeah, so if you put mine. I even want to say, like, like you can write things down as you start. Okay, and then finally, parenthesis, n minus 1 is also. So that's the whole thing. That's what they mean standard form. Now you go ahead and distribute by like.
Oh, I think so. I think I got rid of one of the variables we had.
Distribute it and then just make it.
There's this new one. There's this new one. So after we got rid of the Z, it was quite. Well, we got rid of another variable. It's for. We did it with the negative. Yeah.
Also,
So,
okay. Yeah, the flip side. So you know that is mine, you know. That's another one.
So this equation is that one.
And you like.
So I have to simplify this one.
Base is 1, you can plug in 20 wherever you see that. And then you can mark your 1.
I'm not being purchased.
Alexis, did you try to do number 4? Okay. Now, to be fair, Alexis, oh, you're working right now. You can also just remind everybody how to plug it into their calculator. I don't think you were here the day before the calculator. Yeah, matrix. Oh, you can't do it. Okay, well, yeah, so that'd be one option as well. But yeah, elimination and substitution. If you're not quite sure, I could always do that one on the board, because I wouldn't mind showing everybody. And then you could take number 6. Does that sound okay? Okay, let's do that. Okay, well, let's get started. All right. So number 2 was performed for us by Oscar. So number 2, let's see, where did Oscar do it? Over here? Yeah, here we go. So Oscar has 4y plus x equals 24, and then y equals x minus 1, and it says to do it by substitution. So notice the instruction says substitution. So in order to get full credit for this problem, you have to do substitution. That doesn't mean that you can't do it by elimination or matrix on your calculator to check your work and check what the answer is. You can solve the system any way you like to get the answer so you know what the answer is. But then to get full credit for the question, you have to show me the act of substitution. Okay? So is that fair that on the test you can use your calculator matrices, you can do elimination, you can graph it, you can find the answer any way you like to check the answer. But to get credit, you need to do substitution. And so that's what he did. Notice Oscar even showed us that this was a substitution sentence. He plugged the x minus 1 in for the y. He distributed his 4, combined like terms, moved the numbers over, and he got x was 5.6. Then he took his 5.6, plugged it back into his substitution sentence, and he got his other answer, 4.6. Now, again, the decimal might make you feel uncomfortable, like, oh no, did I do it right? So, Oscar, how do you know you did it right? How do you know your answer is correct?
You can always check it.
Yeah, you can check it. How do you check it?
So you just plug the numbers back into.
Yeah, exactly. Just plug the numbers back in, folks. And again, it's your test. Do you want to know that you got the answer right before you turn it in to be graded? Of course you want to know you got the answer right. So you would take those 2 numbers and plug them into both of these to check to make sure that it gave you the correct answer. So in this case, right here, let's see. Oscar's 4 times y is 4 plus 4 is 16, 18.4 plus 5.6. And sure enough, that is 24. So the first equation is true. And then here, 5.6 minus 1 is 4.6. So that's true as well. So yeah, Oscar got it correct, and that would be full credit. Okay. And then for number 3, thank you, Oscar. Number 3 was performed by Jose. And number 3 was solve this system by elimination. So again, you can feel free to solve it with substitution, calculator matrices, graph it, but you have to do elimination to get full credit. So he chose to eliminate the x variable. Notice you could have eliminated the y variable as well, but he chose to eliminate the x variable, which is a perfectly fine choice. So he multiplied through by -5. He wrote down his 2 new equations, eliminated the x, got -14y equals 42, divided off the -14 and got y equals -3. From there, his y equals -3, he plugged it back in to either equation. He chose the second one because it was simpler, and he solved for x was -4. And Jose, how do you know you got it right? Well, I didn't write it down. Right. So, but you did plug it back in. Okay. So yeah, and then by plugging it back in, I'll go ahead and do it. 5 times -4 is -20. -4 times -3 is +12. And sure enough, that's -8. So that's correct. And then the second equation, -4 minus 6 is -10, and that's correct. So yeah, he definitely got it correct. Okay. Now, number 4, folks, let's take a look at number 4 here. It says solve the system of equations using elimination or substitution. Now, to be fair, we've already found out how to do a problem like this using your calculator. And so maybe you're thinking to yourself, geez, I'd much rather just use my calculator. I mean, I can just plug it in. So let's talk about both ways. Let's talk about how you do it with a calculator and how you do it by paper. First of all, somebody emailed me and they said, this equation does not have a z variable. So how do you plug it into the matrix? So this is a really good question. So where is the z variable? It's 0z. Yeah, so there is a z variable. It just has a 0 in front of it. So this equation is actually +1x minus 3y plus 0z equals 9. So if you did want to write this whole problem down as a matrix, you could say my coefficient matrix A is 2, -5, 1, and then -1, 1, -1, and 1, -3, 0. That would be your A matrix. And then B would be the answer matrix, which is 17, -5, 9. And then to get your actual answer, it's always just A inverse B. And you would type that into your calculator, and you would get your answer. Right? Well, okay, so good question. But the question says to do elimination or substitution. Now, there's no problem at all with doing it this way. Why not go ahead and do it this way and find out what the answers are? Right? I mean, I feel like I've been saying this all along throughout every test is cheat, find out the answer, and then make sure that your work is correct, right? And now obviously it's not really cheating to use a graphing calculator to find out the answer. It's not cheating to use your matrix calculator to find out the answer. It's just good math. Check to know what the answer is, and then go ahead and do the problem. Now, in a problem like this, it's actually not that challenging to do the substitution or elimination. I'm going to do elimination. Remember, what we want to do is eliminate the same variable twice so that you create a new system in just 2 variables. So right now we have 3 equations and 3 variables. I want 2 equations and 2 variables. And so make a note to yourself. What you want to do is eliminate all z variables. Because if you eliminate the z variable, then you'd be left with equations that are just x and y. So notice, that's actually how they set you up. Look at those first 2 equations. Are you ready to eliminate z? You're ready to eliminate z. One's plus, one's minus. So I'll go ahead and add those 2 equations together. I get 2x minus x is x. Negative 5 plus 1 is negative 4y. And then the z's cancel out. And then 17 minus 5 is 12. So there's one equation in terms of x and y. And here's another equation in terms of x and y. So in fact, this problem, you don't even have to do much elimination before you get down to just a normal system. Now this normal system right here, again, you could use your calculator and do the inverse method to get the answer, or just go ahead and do it. How would anyone in here, how would you want to solve that? Elimination or substitution? What would you want to do?
Elimination.
Yeah, I would probably do elimination as well because the x is already a 1 on each and I just need to change the signs on one of them. So this bottom equation, I'm going to change all my signs. Remember, that means multiplying all the way through by -1. So that becomes negative, that becomes positive, that becomes negative. Now I can add these together. The x's cancel out and I have -1y equals 3. And if I divide off the -1, that tells me that y is -3. So that's my first solution. And now I have to back substitute in order to solve for x and y. I'm sorry, x and z. So now that I know that y is -3, I can go ahead and plug back into either of these equations to solve for x. I'll do the first one. I have 1x minus 4y equals 12. So if I plug in -3 for y, I have 1x plus 12 equals 12, which means x equals 0. So that's my second solution. Now I have to back substitute again to solve for z, so I can plug those 2 answers for x and y into either of these equations. Which one will I plug it into? Oh, the second one, because there's less coefficients, less to multiply. So now I plug into this equation. I'm going to write it down first. -x plus y minus z equals -5. So now -x, which is 0, plus y, which is -3, minus z equals -5. So that's nothing. -3 minus z equals -5. If I add 3 to both sides, I get -z equals -2. Divide both sides by -1, or multiply both sides by -1, or just change the signs. I get z equals 2. So in theory, at least, my answer for x, y, z is 0, -3, 2. And at this point, I think you'll all agree with me. Am I done? Oh, definitely not. Right? I mean, at this point, I could have made so many mistakes. I have no real guarantees that that's the right answer at all. My goal all along was to find 3 numbers that I can plug in to make all 3 equations true. So that's what I have to do now, is to actually check. Well, then again, if I did the calculator method, I might already know if I'm right, because the answers will agree. But now let's check. If I plug in 0, -3, 2, that'd be 0 plus 15. 15 plus 2 is 17. Good. That equation's true. 0, -3 minus 2 is -5. That equation's good. And then 0 minus 3 times -3, that's 9 equals 9. That's good. So in fact, the solution works. All 3 equations are true. So how do you get full credit on the test? You do elimination or substitution. How do you make sure you have the right answer? You can plug it into your calculator and do the inverse method. If you just write down the calculator solution, and you say, Mr. G, I solved this with my calculator. All right, good job, -5. Right, because I'm glad you know how to use your calculator, but you do need to show the work using elimination or substitution. I always have a lot of students who ask me, why do I have to show my work in this particular way? You know, isn't it good enough that I just get the answer? And I always think the answer to that is like, if you're taking a karate or taekwondo class, have any of you ever studied martial arts? Anything like that? Maybe a little? Well, like, what if you showed up at a competition and like you're supposed to do karate or taekwondo and you show up with a knife and you just stab the other guy? It's like, yeah, you didn't do the thing, right? You're supposed to be doing taekwondo or karate, not just bringing a knife. It's not fair. So that's what we're talking about. All right, we've got some more people coming up here. That'll be Emmanuel and Evan. Let me change the screen real quick. Number 5 and, oh, actually, this is just number 5, but maybe Evan. Evan, you can come on up as well and just write your answer for number 6 up on the board somewhere. So 5 and 6, let's have Emmanuel and Evan come on up. I'll leave my matrix solution there just in case anyone's still looking at it. Oh, pardon me. So no questions. Actually, don't know how to say it. You know what I would do? I would go ahead and take, say, kind of that a lot. Just look at the word problem. Take out a separate sheet of line paper and do as much as you can. Okay? You know, read each sentence, one sentence at a time, write as much as you can. And remember, you can write down the steps. You can say, draw a picture, identify the question, find your variables, and build your equations. And use that as your steps. So, picture, question, variables, equations. And then you see how far you can get. And however far you get, then go ahead and look at it. And then you'll say, oh, yeah, that's the next step. Then go back up and keep working. You get as far as you can. Then you now look, take a peek, say, oh, yeah, that's what you do. Go back up and finish your work over here. So all you're ever doing is momentarily, quickly glancing, and then going back to work. Then what you do is you touch your one paper, put it away, take out your sheet one, start from the beginning. If you just keep doing that over and over, you'll eventually see how you do the whole process yourself. Really truly, I don't know. Just the only way to build things that I haven't. Yeah.
No.
No, probably not. It's just a regular. Yeah, that's it. Plus, we don't even know the formula. Yeah. Yeah, the formula's terrible. It's tough. That's why we do it. All right. Jonathan. Okay, great question. Okay, so on the one hand, we're looking at it, right? And so the first thing we do is pretend them and just analyze them separately. So what's happening with them? Sure, and now. So 1, 7, 49. What do you do? How do you go from 1 to 7 to 7 to 49? In 1 by 7. So far, we know that our rate is equal to a common ratio. We're multiplying over and over and over by 7. Now let's look at the numerator. 10, 60, 360. What are we doing on top of this? Yeah, we're multiplying by 6. And therefore, that's our ratio. Now, the other way to do it is, I see why it's tricky, because you are doing decimals. And roundings, you can totally do decimals. In fact, I mean, that's a fine approach. What was that, 60 divided by 7? Oh, that's why I didn't work. Because 60 divided by 7 is not actually 8.57. 8.57. So, rounding to a decimal is all in rounding a decimal should be considered easy. Yeah, because rounding a decimal is one. Right? It's not even really the answer. It's just some approximation to it. So, so instead, don't do decimals. Instead, what we learn in class was take any fraction and divide it by 1. That's a common combination. So if I take 360, divided by 67. So that's actually going to be 360 times 7/16. Now we can just go through 7 goes around 7 times, and then 60 goes around 6 times, and left 6 times, which again is, yeah. This is valuable when you learn that, because like, what you just learned is that converting to decimals doesn't work. So that's a valuable lesson. Converting to decimals, it works so long as the decimal is not like that. You know, if it really was just 8.5, you're really wrong. Yeah. All right. Well, very good. Great question. Did I answer your question on one? Did I answer your question? Okay, so we got this one.
I don't know, it's just because it's a fraction and then the exponent and it's kind of,
It looks weird,
yeah.
right? It does look weird. And a lot of things in mathematics looks weird. If you try to graph it, it's hard to do. So instead, don't try to understand just do simple stuff. We know that we're going to plug in a number. We want to convert it forward. So let's just find out. We're not even going to try to understand it. We're just going to find the first number. That means A is something 1, and then we plug in 1. So I write down the formula, -1 equals 1 times 16 all over. All over 1. So even now, I'm not understanding what this expression is, but I just plugged in 1 everywhere it's on n. And then 1 squared root of 1, and then the answer is 16. So regardless of whether or not this formula makes sense,
So then, you want to go first for terms that I find the hundred.
exactly. So you're going to plug in 2, you're going to plug in 3, you're going to plug in 4, and then you're going to plug in 5. Yeah. And does the formula represent anything? I mean, maybe it does, maybe it doesn't. Ultimately, what this is going to represent, the first term is -16. The next term is going to be positive, because it's going to alternate from -1 plus 1. So the next one, that was 16 over 1, so then -4. So -16 over 16. No, -5. And right now, you can kind of see there's not a pattern. The numerator is always 16. But it alternates minus, plus, and denominators are square numbers.
Oh.
I have 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. That's it. That's the whole sequence. So what we're really saying is that if it's an odd number term, it's negative. Even number term, positive. And then we're saying that the denominator is that term squared. So I can already predict how many terms. Since 100 is even, it's going to be positive. It's going to be 16. That's going to be over 100 squared, which is 5. Okay. Now, does this formula make any more sense now? Because all I'm really saying is alternate signs always, make the numerator 16 always, and make the denominator square. Okay. So, and then how did we figure all that out? Just by looking at the terms and thinking about what's happening. Now this equation makes sense. But at first glance, it won't really make sense. What you need to do is just start plugging in numbers and getting the sequence. And then once you see the sequence, it makes sense. Does that totally make sense? Okay. Yeah. I left it. Thank you. I was wondering about it. Okay, let's take a look at a couple solutions before we go. Number 5 is a manual. Oh yeah, the manual. You had quite a few to do. So first, number 5, given the matrices, compute A plus B. So here, manual gave us A plus B, where you just add entry by entry by entry, and this looks correct to me. Anyone disagree with any part of his work? No, that looks right. So that's A plus B. Next, negative 2A, so multiply each term by negative 2. And so again, Emmanuel's work looks correct. You're multiplying by negative 2, that's correct. And then, given the matrices, you have to multiply them. This, we didn't really talk about how to multiply it by hand. You know, that would take much longer to review that skill. So we talked about just doing it on your calculator. So you enter matrix A, you enter matrix B, and then you multiply them. And Emmanuel got the answer 6, 7. I'm assuming that's correct. Did anyone else get 6, 7? Okay. And then finding the inverse matrix. Again, this is just a calculator skill. You plug in the matrix 2, 13, 11, 71, and then you hit the inverse button, and you get negative 71, 13, 11, and 92. So Emmanuel, all that looks great. Now, again, folks, today, while I'm walking around the room, if you need help with your calculator, this would be a really good time to ask. And I even brought more calculators, just in case somebody doesn't have one and you want to review how to do it before the day of the test. I'll bring these calculators back. So if you need a calculator and you want to practice calculator skills, please let me know and I'll help. Okay, thank you, Emmanuel. Now let's see, number 6 was done by Evan, which is right over here. It says, solve the system of equations by converting to a matrix and using the inverse feature. Oh, no, just look at this, folks. I mean, doesn't that look like a simple way to solve a system? Who wants to do substitution or elimination when you can do this, right? Talk about snapping. So Evan took the coefficients from the x and y variables. He took the answers from the right-hand side. He plugged them into his calculator. Then he did A inverse times B, and he got 8288. Now, is Evan correct? A couple people are saying yes. I have no idea. I would have to take 82 and 88 and actually plug them in and see if they worked. And then you'd feel very confident that that's the right answer. So do they work? All right, I'm just trusting all of you that it works. We could always just plug it in, though. Pretty simple with your calculator to plug in answers. So it's going to be negative 2 times 82 minus 3 times 88 equals negative 428. That one worked. And then negative 82 and then plus 3 times 88 is 182. So yeah, it does work. And that didn't take very long for me to check it on my calculator. All right, thank you, Evan. Well, let's go ahead and take a break. Time is 9:04. Let's be back at 9:14. I think I have papers to get back to.
Yeah, he did.
I finally saw that comedy bit of the Jay Cohen. It showed up on my Facebook. Yeah, have you ever seen it? Yes. And then at the very end, you was like, one of the students just made it present it present. But it's nice. The very end, the teacher said, did you get a practice file? Okay, there we go. Okay.
Oh. I swear. Teach you how to
A lot of you will be familiar with this strange identity here, 1 plus 2 plus 3 plus ... is equal to minus 1/12. Now, when you think about it, this looks totally insane, because what we're doing here on the left side is we're adding larger and larger positive values, infinitely many of them. So if anything, this left side... Welcome to the first mythology video of the year. Today it's about something very serious, and so I'm wearing a totally black t-shirt. You all like number file, right? Me too, except for this one video over there in which they prove the infamous identity 1 plus 2 plus 3 plus etc. is equal to minus 1/12, using some simple algebra that even kids in primary school should be able to follow. Since this video was published in 2014, over 6 million people have watched it and more than 65,000 have liked it. Unfortunately, pretty much every single statement made in this video is wrong. And by wrong, I mean wrong in capital letters. In particular, as anybody who knows any mathematics will confirm, 1 plus 2 plus 3, etc. sums to exactly what common sense suggests it should, namely plus infinity. And this video was not published on the 1st of April. Also, as we all know, the number file videos are presented by smart guys, in this case, university physics professors, who do know them.
So there's a translator, right? Right. So they didn't talk about it. But not that she talked to me. But the translator was talking about it. And they're both in the same room. So it's like much of words finding into what is written. And I don't know what I'm talking about. And because like I'm hearing translators translate, now they're asking what she's saying. Like, I try to understand it. Like, I knew what he was saying. I heard him, but it was weird because his words and the translator was like rushing together.
All right, folks, I think we're ready to keep going. I'm going to find a way to erase the word problem.
Like language, like that.
All right. Where did we leave off? We left off, we did 6. All right, 7. So come on up, Drea and Ashley. 7 and 8, Drea and Ashley. Otherwise, I'm just going to keep walking around the room, helping people as we go.
So, you have this coefficients of x, coefficients of y, and then so we're going to do is set 3 different matrices. The first matrix, which is matrices. The first one, which is set up, is just coefficients of x. So the first one I'm going to set up 1, 6, really. 2 by 2. It's technically a determinant. So what is it? And I think you can do is just 2 minus 8. Yeah, so it's fine. Next, we're going to set up a determinant called p sub x. And what that means is we're going to use, instead of putting these coefficients, the 1 and the 3, which are exponential, instead of putting 1 and 2, so we're just going to swap those out. 5. And put in the normal y coefficients. So those So that's what we did so far. So X replacing the X coefficient. Then we're gonna make a new equation. That's Y. Then in that case, we're gonna replace the one by the so now we're gonna make it. And then leave the original. Yeah, exactly. We're just replacing. So you'll notice we have the original coefficient and Y. Then we replace the X. We replace the Y. So when those three determinants, I divide them into and then this solution for the point of intersection space. This simply the X variables and the Y. And that's just one. So try that out. Try and see what happens. Yeah, right. So the street total determines the first is using and that's the one. Now we're going to see the piece of X. So far, we've done swap. Now we're using Y replace the Y. Now we're here. The second term and then the normal one intersection is
And I think because they asked me for once upon. Yeah, right before that. So, he's like, honestly, I was like, okay.
Okay, well, that's fine.
So I was like,
That's the way.